Hello, everybody. Good morning, good evening, good afternoon to all of you guys attending this webinar. My name is Armando Lacerda, and today's topic is Power BI, and in particular, large data set performance tuning tips. How to work with data in Power BI when the data doesn't fit in Power BI. So we're here with Wintellect, gonna do some introductions. Wintellect is a consulting and training company. I've been working with Wintellect for quite a while. I've been delivering classes for Wintellect on Azure topics, and yeah, mostly on infrastructure and development. And I'm also a database data platform guy. So a little bit about myself. Again, my name is Armando Lacerda. I'm a senior BI and Azure architect certified by Microsoft. And I'm also a Microsoft MVP. MVP means a guy that likes to share what we know, what I know with the community, like this opportunity here. And in particular with Power BI, I've been working with Power BI for the past 4 to 5 years. I've actually been trying out Power BI since inception, about 5 years ago. And all my projects for the past 3 years, they had Power BI involved in a way or another to present data. But I'm not your typical Power BI guy. I'm really the guy who works behind the scenes, working on data modeling and Power BI performance. So I'm not the guy who goes on and create reports. Of course, I can create the reports, but I'm very specialized on on the data is really large, and then when people don't have the technical skills to work with some constraints in Power BI, so they call me and we start working on how to get, on getting data in Power BI working faster and in volume. Yeah, so that's pretty much about me. Let's go ahead and jump into the agenda. So for this morning here in the West Coast, I'm in California, enjoying the summer weather, which has been pretty cool. Finally got some suntan after a while. And so in this morning here, we'll be talking about the engine behind Power BI, how Power BI deals with the data, what's going on behind Power BI, so we can understand how it works. And if we grasp how Power BI works behind the scenes, we will be able to help it out dealing with the data and dealing in the way it best dealing with the way with best design is the way Power BI likes the most. So we're gonna see the database behind the scenes, the database engine behind the scenes called the VeriPack and the X Velocity. We're gonna understand how columnar store works, and that's a very important thing because most of the time, I'm gonna return to this topic later, most of the time people get in trouble in Power BI in terms of performance and also with large data sets, because we are so used to work with relational models and the normalized forms and all of that. And when we try to apply that to the database type that is behind Power BI, we usually get in trouble. So we're gonna take a look on that. And throughout the session, I'll be working with the Stack Overflow database. In case you are wondering, the Stack Overflow database is the Stack Overflow is a website that helps developers. That's one of the hats that I wear. So Stack Overflow, it's kind of a community website, and here people exchange questions and answers, and those developers helping developers. So there are a bunch of, let me see here, Stack Overflow, probably this guy. Yeah. So there is a bunch of posts in here. And again, it's like a social media, right? You enter a post, you add a question there, and the community will try to help you out. This is all open source, and the beauty about this is because it's all open source, from time to time, they decide to publish this database, removing PII information, right? But they make this database public, and we can create demos like this one on top of this database. So in our case today, I'm connected to an Azure SQL database, this guy here. And if I go here to the portal, you can see here the database I'm going to work with in Power BI. And this database is 420 gigabytes of data. If you know a little about Power BI, you know that this is too much data for Power BI, right? When you work with Power BI compress the data. You're going to see more about that. But when you bring data into Power BI compress the data and has an excellent compression algorithm. I have seen getting down to 10 gigabytes of data when the original data is like 100 gigabytes. On some specific settings of data, I have seen that kind of compression happening before. But the main point in here is if you work with Power BI in a regular fashion, you have a Pro subscription, and Pro subscription can upload to Power BI up to 10 gigabytes of compressed data, which could be something around 80 to 100 gigabytes, depending on the data set. But the most important thing is you can upload 10 gigabytes of data, but one particular data set can only hold 1 gigabyte of compressed data. And with this size of data here, 420 gigabytes, it definitely doesn't fit in Power BI. So when you get to situations like that, what can we do? I'm going to give you a few tips, not everything that can be done. Of course, it doesn't fit in an hour session with questions at the end. So we're going to open about, I'm going to end the presentation about 45 minutes after the hour. And I'm going to give us about 15 minutes for questions, if I manage to do that. And but in any case, we're going to show you some of the options, the most common techniques that I use when I'm working with clients. All right. So that's the database we're going to be working with, and this is some of the demos I'll be running through in a second. This is also a demo that will be there in a second. This is my virtual machine. Let me go back here to the slide deck. So that's our schedule for the day. Let's move on. All right, so what's the deal about columnar storage? It's very important to understand the difference between one and the other. And the idea here is, I'm going to illustrate it for you here just quick. Let me get here another Power BI, another PowerPoint presentation here going on. So when we create a table, let me change this here to blank, and let's insert a table so you can have like a visualization of what I'm talking about. When we create a table, let's say this is a table in one database, like in SQL Server, and let's say this one here is my ID column, this one here is my name column, this one here is my email column, and this one here is my quantity assigned or something, and many other columns, right? Column 2, column 3, column 4, and column 5. So here's the deal. In a regular SQL database instance, and I'm doing this in a very slow pace so you can follow along because it's not very, let's say, common concept for relational people, for relational databases. When we are working with Power BI, when I work with regular databases, and I'm looking here for my, funny thing, I'm looking here, there you go. For my cursor was not showing on the screen for some reason. So when you collect data like select name from my table, which is the table below, when I do this in a regular database like SQL Server, in our mind, we have this idea that SQL Server will go through my table, and SQL Server will go through my table, and it will collect data from the name column, right, from this column here. But that's not what actually happened. This is what we'll get as a result, right? SQL Server or any other relational database will give me just the data of the column name from as an answer for my query. But what actually really happens in SQL Server is it goes through all the columns on on my table because it has to go row by row collecting the data from the name table. So what really happens is SQL Server and any other relational database you probably know of or work with, SQL Server will read the entire table. In this case here, there is no where clause. So it's going to read through the entire table to return to you just one column, right? You want to see just that column over there, the column name, but it will read through the entire columns. And that's very inefficient when we are doing data analysis, because if you're doing data analysis and you want a total of quantity, for instance, the data should be reading just quantity, right? You should not be reading all the other columns, especially if the other columns are quite large, because this decreases performance. So that's the main difference we have to start with when we are working with Power BI on large data sets. Here it's important note I've just mentioned that you have to keep this in mind when you are working with large data sets. But most people work with Power BI with small data sets. It's like you go into a data set, you go with a data set, you populate that data set with data coming from like Excel spreadsheets. It's coming from small tables on a database someplace, and because the database behind Power BI is so well designed, so fast, because it's all based in memory, that you really don't have to care much about this when you are working with these small sources, because although my design may be not that good, the speed of the data engine behind the scenes is so fast that it it shadows my mistakes. The last time I have seen a white paper from Microsoft about the speed of the database engine behind Power BI, it was back from 2012, and it was able to read 5 million rows, to scan through 5 million rows in a column in less than a second. So it's that fast. So this kind of worries here I'm mentioning to you, they usually don't apply with the databases that small, but in our case here with my tables here, it will be really big. So I have to be aware of this. And there is a way to demonstrate that. Let me go back here to the virtual machine. There is a way to demonstrate that pretty quick. So let me show you how that impacts our work. And the best way to show that is actually using SQL Server, because Power BI only works in tabular mode, which is the column store. I cannot make a comparison Power BI. So let's jump here into SQL Server just quick, and I will show you how that works. So I'm gonna set the statistics on so you can see the query going on and how much reads it goes through. And just for you to understand the database in here, just from the Stack Overflow, you can see here that I have a bunch of tables. Most of these tables here, they came from Stack Overflow, but the one I'm gonna make this demonstration here on is on the comments table. This first demonstration is on the comments table. So the comments table is one of the largest ones in the database. It has about 22 gigabytes, I think, 22, 25. And I have two versions of it. This one here, this first version, it is the regular table, the table that came with, actually this one here is the regular table, the table that came with the backup from Stack Overflow. And you can see here that I have a pretty large column over here, text, which what is either the original post or answers to the post. So all the text people type in here. And they have a bunch of other ideas on this table. So in this particular table here, this is the original one, I have no column store. This CS here is my acronym for the column store. I have no column store index, so it's what runs behind Power BI. This one here does, the top one here. So if I open here on indexes, you see here that I have a column store index, so we can compare performance from a regular table and the kind of tables that exist underneath Power BI. So let's take a look on that performance. Let's compare their performance doing some queries. So the first query here is collecting data. I want to see how many rows. I want to count rows. I'm not actually returning any column from the result. I just count the rows. But again, because Power BI I'm sorry, because SQL Server, the regular SQL Server does this row by row, even though I'm just counting rows, it has to scan throughout the table. So it's going to jump up row by row, and you will see that that's going to take a little while. And even though I have a robust Azure SQL database behind this one here with 14 CPUs, I'm expecting this one here to run in about 3 to 5 minutes. So we're going to let it go, execute, and it's processing. See, 1 second, 2 seconds, trying to go through the table. This is going to take, like I said, a very long time because this table, this query is query all the rows, not query just one column. The column, any column I would like to count data on. So what I'm going to do while this one is working is I'm going to do this other query here on another session. So there will be 2 concurrent queries to the same database. So I'm still in Stack Overflow database over here, and I still want to see the statistics to see how much pages, how much IO this one is gonna cost, is gonna generate. And now I am, see this one here, I'm counting how many posts or comments a particular user has posted. And this one here, I am count how many posts have a particular score of 3. So why am I using scoring here? Because on this regular table, comments table, my index over here, let me see, index, there we go. My index here, this guy here, it is this index is created on the score column. So let's take a look here. Let's see, script index, create, new query window. So that's the script that create that column or table in there. I actually have score and ID. I can use both. Look at that. So let me close this one here. So yeah, same query. Let's use ID here just for fun. Change this on the fly. Same query over here. Execute on another table, right? This is comments. And look at that. I already have a result. So just came like 0. 0 is not fun. Let's try another one here. Do this again. On the score equals to 3, and is executing my query. So we see this query was answered in 5 seconds, and while the other query maybe still processing. See, it's running for 2 minutes already, and it is still processing. That's the main difference in between the engine behind the regular database system, which is this one here, and the engine behind Power BI, which is this one here. It not just process things way faster, but you can see when the other result comes back, it generates way less page reads. So I have here my logical reads on pages on this particular query here. So it's just about this amount of pages here, 157,000. You're going to see the other one is going to be way larger than that. And why is that? Is because Power BI, instead of reading row by row to return a particular column, what Power BI does is it reads the column, only the column I refer to. And here is a very important lesson when we are dealing with large data sets in Power BI. As much as possible, I want to work with one column when I'm collecting data, when I'm creating my measures. I can filter by multiple columns, but if I have to do calculations in my DAX, which is a topic down the road here in this session, if I'm creating a calculation using my DAX formulas in between more than one column, that will slow down my process because Power BI will have to scan through more than one column to get to my results. It may not slow down that drastically, depending on my filters, but in any case, it will slow down. So we're gonna get that to that point in a second as we move along. So again, columnar storage is different from relational storage. Regular row storage always read all columns, like I mentioned. Columnar storage applies scans only to the select columns in your DAX formulas when you are in Power BI. Again, my demos were in SQL Server because it's easy to compare one engine to the other because SQL Server hosts both engines. But in Power BI, it only applies the lessons here about the column storage. So one column, it scans only through that columns. Measures, they will work on multiple columns. They can work, like I said, but when you do that, you're usually compromise a little bit on performance. Sometimes it's because of the filtering. If you're not working with that large amount of rows when you're doing your DAX, you may not even see the performance impact. But when you're working with a lot of rows, low filtering level in your query, then you see some performance impact. In that particular case, the main lesson here is this one here. See, take advantage of pre-calculated columns. That's a very important lesson in there, because if when you go into Power BI, let me go back there to the virtual machine so we can discuss that a little bit. So if I go into Power BI, let's see here, I want to, still refreshing. This is something else I'm working on. My virtual machine is pretty busy at this time. But here on demo 1, where is my demo 1? This is not it. Might be this other demo 1 here. This is one. So when I'm here on my Power BI and I see some tables I have brought in from the Stack Overflow database, if I go ahead in any of these tables here and I go and I create a new measure, if I do a measure like I want, it's processing on the thing, let's just wait here a little bit. All right, so if I want to go here and do like, my new measure is equals to the sum the sum of fn post, let's see here, let's get something here, post, actually, yeah, let's do this, count x of fn tag plus, and come on, fn tag plus the count x of something else. Let's see here, fn post links or something else. If I do a query like this one string is missing the column referencing there, but in any case, if I'm doing a query like this and I'm counting returning results from multiple columns of different tables in my DAX, I would, instead of doing this, instead of creating a measure that would be a calculation between multiple columns, I should rather go in here and create that calculation as new column. And that is your option if you're making calculations within columns on the same table. So when you do your design, you must make sure you have in the same tables the columns you want to make calculations on. Because if you do a calculated column in your table, Power BI will pre-calculate the results row by row. So my new column, and like this column here is going to be post ID concatenated with tag, for instance. So when I do this, I'm referring to 2 columns, but the performance hit will not get on me, because when I hit enter in here, the first time I hit enter, Power BI will make this calculation and will store the result, because Power BI database is read-only until we refresh. So until the next refresh, the data will be stale here in this data model. So what happens in here is Power BI will make the calculation on the model, will store the calculation row by row on the model, and when I do a new measure that goes through the rows, it doesn't have to go through 2 columns. It will go through only 1 column, and that may benefit your database scan performance. So let me get this, supposed to be here. Oh, this guy's working on something, all right. this is supposed to be here. And let me save this one here just quick before I go to the next demo. Make sure I didn't change anything. And we will be back to our slide deck. So I kind of ran through the demos of these topics here as I was presenting on them. So the demos on the Stack Overflow for this one here, they are done. The bottom line here, the first collection of tips for you guys to make sure your databases, your data sets in Power BI are running fast is you should make sure that your decks, they refer to one column, and if they refer to multiple columns when they're calculating data and these columns are on the same table, you should create new calculated columns so your engine, the Power BI engine, will work faster when filtering and making the DAX calculations for you. So that is one. The other one is going to be like a deep dive here. So, fasten your seatbelts and put breath in your lungs, because this is going to be a really deep dive one, so you can understand some other elements behind the Power BI data engine. Talking about that, let me go back here just quick and see this one here. Just wrap up that demo over there. The other query must be done by now. So the other query took almost 3 minutes and 38 seconds to return the same amount of rows. And here you can see that this one took 2 million. Took almost 3 million page reads, right? While the other one, like I mentioned before, was about 106 million. So it's what, 0.5% of reads, and they're all done in memory. So that makes it really fast, right? So again, try to work with one column only. All right, so back into slide deck in here. The next thing to learn about the Power BI engine, the next thing to learn about the Power BI engine is that it's pretty much split into two main portions. One of the portions is called the formula engine. You can see it here, right? It's called the formula engine, and that's the one that makes all the DAX almost all of the DAX calculations, all the complex ones we have when we use related rows and things like that. DAX functions, they are really complex calculations. They usually depend on the formula engine to do those calculations. And there is a second portion of that engine in Power BI that's called the search engine. And the search engine is the one that makes Power BI so fast. It works on data that's in memory. Power BI never relies on disk I/O, so it's always that fast. And what Power BI really likes to do is to search for data. So when working with Power BI, we want to focus on filtering. We need to filter in order to focus on the data we're working with. So filtering is processed by the search engine. And when finding the rows we want to work with, the search engine is able to do simple math operations like sums, multiplications, divisions, subtractions, of course. So it's able to do with this very simple math operations. Anything that goes beyond that, like string comparisons and if statements, case statements, they have to go to the formula engine because it's more complex than the search engine was designed to work with. So Armando, why is that important? Why do I have to worry about having these two guys in there? The answer for this question is the formula engine is single-threaded. And the single-threaded means when someone needs calculation, this guy here is going to create a queue. The formula engine is going to create a queue, and will handle one calculation at a time. While the search engine is really multi-thread. And multi-thread means that it's able to multitask. It can all these simple calculations and filters. filtering on the data, they can be done in parallel, depending on the computer behind your Power BI, depending on the subscription you have. You can have like 4, 5, 6 working threads working in parallel with distinct portions of your data, and then they combine the result to get the data really, really fast. A good comparison of this, I was thinking about that this weekend while I was preparing for this session here today. If yeah, this is kind of improvisation here, just try to get this concept pretty clear. If you go here to San Jose, California, this past weekend, I'll make it down to Monterey. It's a city here, kind of a nice, pretty city here down here. See, Monterey is down here. A nice, pretty city here in the California coast. But to get there, I live north of San Jose. To get there, you have to drive through 101. And the thing about 101 going south is up here, it has like 5 lanes, and then it goes down to 4 lanes, and then it goes down to 3 lanes, and then it goes down here to 2 lanes. And there is always traffic behind this thing here because you are reducing the parallelism. So when you get the reduced of lanes, you always get that back traffic behind that point where the lanes shrink. And that's the same concept of Power BI. It's the same concept in here. If I have 6 guys working at the same time and then they need this one to do a process for them, they will have to queue up behind one another waiting for this guy to do the process. So the bottom line is, when I create my decks, when I create my reports, I need to make sure, especially if I'm working with that much data, I need to make sure that my decks, it's not overusing my formula engine. Sorry, my formula engine. And we can figure that out, but we have to use other tools besides Power BI to find out how my DAX queries are behaving, are working. And the tools, they were created by this group here down in Italy. It's called SQLBI.com. The website is called SQLBI.com. So let's wait a little bit for this guy to come in. Yeah. So they have a bunch. Did it crash? Oh no, they finished saving. Perfect. So this guy here has a bunch of tips, for you. You can sign up for the newsletter. They are around the world teaching their classes in Power BI and in DAX. I have not taken a class with them. I kind of know them in person. We have been in some conference together, but someday I'm gonna sign up for one of these classes. The next one is in Denver, it seems. But the point here is they make these tools. And there you go. They make these tools here for free. And I'm going to be using 2 of these tools here today to show you the internals in Power BI. The first one I'm going to be using is this guy here, DAX Studio. So let me go ahead and pop it up. DAX Studio, here it is. So I'm going to pop this guy up, and DAX Studio is coming. And DAX Studio will help me out to find out what's going on with my query. So here in DAX Studio, I'm going to choose which Power BI I want to connect to. And I think it's this one here. Connect. And yeah, my 3 data sets I have brought from the Stack Overflow database. So here they are. I'm going to use this guy here to find out how my queries are going. So let me go back to Power BI, demo 1. So this file name here is called just demo 1 Power BI. I already checked that out. So this one here, I have two tabs. One is the bad DAX, and the other one is a better DAX. And the goal in here, it's pretty simple. It's not really one of these analyses we do all the time in Power BI. This one is just to make the point of querying data from my model. So let me zoom in here in this model just quick, get more real estate on my screen. So what I have in here is a table called posts trimmed. I have removed some of the columns just to make sure they fit well in here. So I have post streams, and what we have in posts is nothing else but the collection of posts that have been placed in the database. So I have a bunch of keys in here, but the answer I want to get from this model is, how many questions, because posts can be questions or answers, how many questions, I mean, how many yeah, that's right. How many questions have been answered, and what is the likelihood of a particular topic to have more or less answers? So I just want to see, if a post was from a particular topic, if it got answers or not, and of course, how many answers. And I figured that out by using these two other tables in here. There is one table called post tags. So when people make questions, when they post questions in there, they're like, this question is about C#, this question is about Power BI, this question is about DAX, this question is about this or that. So there are multiple tags to a particular post. It can be multiple tags to a particular post. And if I post got answers, there will be entry on post links for the answers. If there is an answer, at least one guy contribute to the post with one answer, there will be a row in here. So what I want to find out is, for a particular tag, show me or count me the posts that had answers to it. That's what I want to do. All right, hope that makes sense. So when I go back in here and I go to my bad DAX, you'll see that this bad DAX here will take a little while to process. Not just because my server is busy, that will also make take a hit on this one here. But you see how long it's spinning here trying to process that. And the idea here is, when I get this kind of behavior, this, like, if this was for a end user and the end user is waiting for the result of that particular question, you would have moved away already. You would have opened a ticket, say my computer is too slow, or this thing doesn't work, or something like that. Bottom line is, people would not be happy at this moment working on this guy here, right? So I need to figure out why this thing is so slow. So what I do here is, I'm gonna collapse this guy here, and I'm gonna ask Power BI to show me, view this little tab here on new release of Power BI Desktop called the Performance Analyzer. And what the Performance Analyzer tells me or shows me is the query, the DAX query behind the scenes, trying to publish this guy, to come with the final result for this visualization, or in this case here, for any visualization would have on a particular report. To make things simple, I have only one visualization going on. So let me click on this guy here, and let's see, like, it's telling me here already that the DAX formula for this guy is this one here. So when I click on this one, the DAX formula is going to show up in here. I'm going to make it easier for you guys. I'm going to get this formula here and copy it to the clipboard and open it someplace else. So actually, I think I can do it right here on DAX Studio and make it a little bigger. There we go. So this is my my DAX formula, the bad one, right? See the bad DAX. And I'm gonna give you like 30 seconds to scan through this DAX in here and double check that it does what I told you. It looks for posts on a particular topic that had answers connected to the question. So in this case here, it looks for CSS topics and on the post tag. So give me all the rows in post tag for that one, and then tell me how many rows you find in the filter trimmed, which is the posts trimmed, which is the main one. So these are the questions that got answers on the CSS. But to make sure, to validate that this particular question had answer, I need to check on post link if that ID shows up on post link. So this DAX here it's a DAX created, is actually a DAX created by someone that has the relational model in mind. So it's pretty much doing a join, like a select count star from fn posts trimmed, inner join, which is the other one, fn posts links on the ID of each one, right? Just for shorting here. Come on, the ID of each one, and oops, just ID, thank you. And also inner join on fn post tag on IDs as well, ID from one side and ID of the other side, where the column on the post tag, or the column tag equals to CSS, right? So that DAX over here, now this DAX over here, is a literal translation of a SQL statement that would look really close to this one here. So this is clearly a DAX formula that was created by someone who is very familiar with relational models, that went to Power BI and looked at the modeling here, say, okay, I can do a join like that, I can get that. And it took that long to come with this result here. How long did it take? Well, let's try it again. Start recording, refresh the visual. So now it's processing the visual again. So it's gonna take a little while. The text box was just 55 milliseconds, no big deal. And the card, which the one showing this one here, is the one that's gonna take that long. When I open this one here, Power BI will tell me how long my DAX query took to get the result back. So I have to do this one again because it's still processing from the previous query. I did not record that, so now I'm recording it. We'll wait for that one. While it's doing this, I have the same result. This number here is going to show up here again on the beta DAX. So here on the beta DAX, it's calculating, trying to calculate the result again. It should show up here pretty faster. Actually, should end before the other one. So we're gonna wait here a little bit for this thing to finish. There we go. See, it was way quicker. So this is my second one down here. This is the beta DAX, and this is the not so good of a DAX, and then the bad DAX that is still performing down here. So let's close this one. This is my one here. And why are they different? Like I told you before, they are different because of the query. So if I look at the beta query, this one here, and I get this query over here, Control C, and back to DAX Studio, and okay, same model, really doesn't matter. I'm not gonna run this right now. So it should be this guy here, connect, and paste, nope, no paste. So let's go back here, this one, copy, come on, copy for me, copy, and paste, there we go. So you see, this DAX here is doing the same work, calculating the same result that this one here does. But but the other DAX, this one here, is not using relational approach to calculate the results, but it's using what Power BI likes to rely on, which is filtering and calculation on only one column. So in this case here, what it's doing is give me all the rows that are CSS on the post tag table, and then count the connected rows in the post links. So where is the post trimmed? Actually, sorry. Where is the post trimmed reference in this formula in here? It doesn't exist. It doesn't have to be there. Why not? Because the model is still processing this guy, so I don't want to switch to the model. It may disturb the calculation? Hopefully not. Let me see. Because the model is already connecting these guys. So when I ask to filter this one here, the model says you have to filter this one as well. So when I connect into post links is already filtered because there is a relationship in between these two. So that DEX over there, let me go back here. So this DEX over here, this particular DEX over here, it's the better DEX in comparison because it relies on the relationships that are in the model. I don't have to make the relationships or the joins, they are already defined. And I just apply filters and simple calculations, not string comparisons or string concatenations or things like that. So that's the reason why this one it's so faster, so much faster. And the other thing here is if I do, actually, if I go back to Power BI, whoops, where's Power BI? Come on, there we go. And this is my BEDEX, finally, it got completed. If I go in here and ask for the query that was behind this guy in here, you see it took that long, that many seconds to calculate the DEX query. Look at that. If I go and look at this guy here and go into DEX Studio and say, you know what, do this calculation here for me. So give me the calculation of BEDEX. This is the bed. Let me get the other one too. Another query here to the same model. Demo 1, perfect. Connect. And if I go back there to Power BI and look into the BEDEX, the same number as you can see, and get this guy here, back into DEX Studio, paste it. So this is the BEDEX. And I'm going to ask Power BI, I'm going to ask DEX Studio to show me the date, the timing of processing this DEX that came from the visual. I'm going to run this guy here. Query is running, query started. So if I go here to server timing, we'll see it's processing my query. It said before there, my query on the BEDEX was not that long. It's like half a second, it seems, right? Oh, this one here, 12 seconds. Still, my service is really busy. So let's go back in here. Oh, there you go. So my query is processed. I need you guys to look at the screen with me here, all the way down, all the way to the left, and look what we have in here. We have the search engine, CPU consumption in time, and we have the formula engine CPU consumption in time. And here's the distribution. So this query here, the BEDEX, was way more reliant on or dependent on the search engine than in the formula engine. And because the search, I have a lot of CPUs behind my my Power BI desktop in here, it was able to do 2.3 threads. It's funny how it does these calculations, but it's like 2.5 threads calculations in parallel. So from 21 seconds total, it actually took 10 seconds because it was in parallel, right? So it's 10 seconds plus 1 second, so about 11 seconds to process this one. Meanwhile, if I ask this one here, the BEDEX here to process and ask for the server timing again, we'll have to wait about 3 minutes like we have seen before to see this result. And I'm going to run it. I'm going to go back to this one later because we are almost out of time. I'm going to go back to this one later here, but I will run this one here so we can see the result on the server timing, and you see that the formula engine is not done yet, still processing, I believe. Let me see, output, result, yeah, still running the query. So this graph is not up to date yet. We have to wait for this thing to finish. I'm going to leave it running by itself, and you're going to go back here later, and you see that the formula engine will be very, very stressed with this one here, and that's the reason it takes so long. So to wrap up this topic in here, what we have seen here is in order to get better performance in Power BI with large data sets, one of the things I have to make sure is that my DEX queries, they rely mostly on filtering and calculations on a single column. Taking away from the previous topic. Instead of the multiple columns, do a single column. And if you see yourself doing queries that are like queries on that it could be easily translated to join statements and SQL Server kind of statements there that are doing filtering based on the relationships on the command itself, you are not doing the right way. And you're not doing the right way because Power BI, although it shows you a model that looks like a entity relationship model, that model is actually implicit filtering. So you must take advantage of the implicit filtering when creating your DAX instead of trying to do the joins and the filterings on the DAX. And I have shown you how you can check out if your DAX is too much dependent on the very slow formula engine and try to tweak your formulas into the search engine. So that was it. To wrap up our presentation, going to the questions. Not sure, I don't see questions here on the stack of questions. So if you have questions, you can start typing them up over there. But to wrap this up in here, the next thing is there is this concept, this idea that when I bring data into Power BI, I should bring the entire data, the minimal, the most granular level of data that I have. And that's not usually the case because Power BI is analytical tool. It's not actually like a paginated report tool. There is a site for Power BI for that, but it's not the one we usually use. So what we really want to do is when your data set is that big, like this one is, you want to apply some techniques to reduce the granularity of the data in Power BI to the minimum possible, so you can produce the data you need without having all the granular data, you have on the original database. Because if you try, you're gonna get an error message. Oops, you're gonna get an error message like this. Go back one. Error message like this. This is the very famous error message when Power BI blows up memory. You don't have enough memory on your desktop to run the thing, and more likely you're not going to be able to upload to Power BI service, because when you get this, your data set is way larger than 1 gigabyte. So what do we do when we get to this? The technique is reducing granularity, or in other words, in more technical documentation, they call it reduce cardinality. Reduce the amount of the individual data you bring in. The common techniques for that are: one, avoid bringing primary keys, especially for your fact table. You really don't need primary keys for the fact table because they don't compress. If you have a fact table that's like 200 million rows, like the ones I'm working behind the scenes here for my next presentation, I'm working with this database I've created on a table that has over 200 million rows. And if I have a primary key for that row, the primary key doesn't repeat its data, so it cannot be compressed. So there will be a column in that that's really, really, really large, just because it can't be compressed. And if you think about that, you need the keys from the fact table to the dimension tables, but you don't need the key for the fact table itself, because you're not doing specific queries on one row of a fact table. You're doing always on range. So you should consider removing the primary keys. Remove the primary key of the fact tables, or the fact tables if you have more than one. Remove level of details, break long strings, and also avoid unnecessary string columns if you don't need them. And just to show you some code about that, let me go back here to the virtual machine. When I do my work with Power BI with large data sets, instead of creating views, I usually like to rely on functions. So if I open here on programmability and functions, this table level functions over here, see I have a bunch of them. I really like to rely on functions because they can be parameterized. So I have more flexibility than in views where I have to do the where columns instead of forcing myself to have a parameter. So for instance, I can show you here the posts trimmed. So if I script this function here to a script, so you can see how it looks like. If I look into this one is getting data from posts, right? So if I look here on the tables and I look here into the columns of the posts table, there we go, columns of the post table. You see that the post table has way more columns than this function is returning, is giving to Power BI. And the reason for that is a bunch of these columns here I really don't need. Like I said, the primary key of the post itself, I don't need. I'm working with aggregated data, so I'm not looking to a particular row. I'm usually looking on rows on a range, like a date range or a particular user range and things like that. So I don't bring this column. This column is just not there. A bunch of other columns, they're not metrics. They are flags that I need to make as metrics. So for instance, this one here, answered, accepted answer ID. A particular post can have, a multiple answers, but whoever posts the question say, oh, this one here fixed my question. So there will be an accepted answer, the only one. I don't need that ID. And that ID will probably not compress well because there will be multiple ID numbers in there. They're always different, and it would not compress at all. But I need to know if a post got answered or not. So my function is given to Power BI, not the ID of the answer, but just a metric that will tell me if that particular post got answered or not. So you see, I am being smart in here, and I'm giving just two values to this column for answered, accepted, and that will compress really well. Like if I have, 1 billion rows on this one here, I have just two possible values, very low cardinality, which means this will compress really, really, really well. So, and this happens a lot on regular Power BI scenarios when you um, work with tables that they don't have the metric, but they have flags, and you want to convert those flags into metrics. Another example here that's very, very important to keep in mind is this one here about the date. So when we work with date, you see, the original one, this is last activity. So last activity should be this guy here. The original table has date and time. And time, in this case here, it's small data time. It goes to the seconds. It may go into milliseconds, I don't remember. But it's a very precise time. It goes to the date and the time. So if I really need to keep date, and I usually do, to keep data in there, I have to ask myself, do I really get to the precision of posts per second? How many posts have been placed in this database per second? Or am I going to work with the date level, just on the date level? So how many posts on this particular day? How many posts on that other day? If I'm going to work on the day level, not the time level, but just the date level, you see, I am making the data type explicit when I send it to Power BI, discarding the time. In this particular case here, I don't want to do it by time. If I want to, I could, I could come in here, and instead of having one column with date and time, I would have two columns. In this case here, creation date as time. So just the time, not the date and time, and call this creation time. So if I really need the time, instead of having date and time, I would break it in two. Why? Again, to help with compression. Because if I have like 2,000 posts a day, they could be compressed on one day. You having just the day or the date will help with that compression. And if I need to analyze it by time, like in between midnight and 3 in the morning, who is active at that time on a particular date or throughout a range of dates, I can filter by 2 criterias. But if I keep these two guys together, date and time, I cannot compress because it's very unique, and it usually is not what I want to do. In this one here, I have 2 dimensions to filter by. If I keep it date and time together, I would have only 1 dimension, linear dimension to filter by, right? So breaking dates and times when needed, it's also a very important technique to make sure that your data compression works fine, right? So this is what we're gonna look for. We are at the top of the hour, time to wrap up this. Just make sure we got this one here right. If I go back in here, remember this one in here, the better DEX relied on the search engine and run really, really fast. The bad DEX relied mostly on the formula engine, and formula engine cannot be parallel, cannot be processed in parallel. So it took that 114 seconds to process plus the time to look for the data. So that's why this query here is so bad. It's because it cannot be processed in parallel and relies on the formula engine that much. So with that in mind, if I go back here to my Power BI, my PowerPoint, I think that's all. Yeah. Do we have any questions, Kimberly or
We do
Martha?
have a couple questions. Yep. First of all, yes, this is being recorded. I'm sorry I didn't answer your question, Sarosh. The next one is from Dan, and he says, Tableau allows you to create a quote, Tableau data extract, which optimizes data and pre-calculates calculated columns to significantly enhance chart performance for multi-million row data sets. Does Power BI have a similar capability?
Great question, thank you. And the answer is yes. And I presented on one of them, right, which is the calculated column that compares to the Tableau calculated column as well to store beforehand the calculations made in between columns from the same table. And the other portion of the question is when we use Power BI, when you are bringing data in. So let's say if I go here into Power BI and I go like, you know what, I'm gonna bring some data in here. So get data from SQL Server, and there we go. So let's go to the local server here to make it quick. And there is a database in there called Dyad, this one here. So when I do import, I'm doing what the author, what's his name again, Martha?
Sorry, it's Dan.
Dan, yeah. So Dan, when I do import, I'm doing what you said. Power BI reads the data from the source, caches the data within the database engine, and never goes back to the source until we ask for refresh. So that makes Power BI really, really fast, as fast as, in some cases, a little faster than Tableau. The other option then is when you do direct query, you don't bring the data into Power BI, and when you do this, everything I have been throughout this session here does not apply, because you are giving up on the Power BI data engine, the column store, and you are relying on the source to give the data to Power BI to render the results all the time. So that's usually really, really, really slow. People who go for this one here, they're usually looking for near real-time data, what's in the database at the time I look at the report. So that's the option to do that. But whoever is using this must be very careful about the source of the data, the database source, because depending on the query, you can have very bad impact in there. I have been cases where people are querying from the SQL Server source multi-million rows all the time, and SQL Server was like, oh, I can't keep up with this. And they have to make very strong investments on hardware in order to support the reports. So the answer is yes and yes.
Okay, we've got another question. Yep, from Sharash, is asking, in a grid visual, what is the best way to use top N? Should we use primary key?
Top N. Well, like I said, primary keys, they work on filtering in between facts and dimensions, and they work on pretty much for that thing, for just for filtering. And you should avoid having primary keys on the fact table itself. So the top end relies on sort order. So you can choose any column to make a sort order and go for the top end. So I would say no, your primary key is not the best candidate for that. Usually you define a sort order on a DEX or even on the visual itself to define which column should be used for sorting, and then you're going to have that top end for that sorting. Because in order to have top, you have to have sorting. So you have to pick up a column for sorting. What's the next one, Martha?
I think you're done. That's it, my friend.
Oh, all right, cool. All right, so I hope you have enjoyed the session. I hope we have, you're gonna walk away with something new in your tool belt to work with large data sets in Power BI. If you have any questions, make sure you connect with me on LinkedIn. Just look, what's my PowerPoint here? Just look for my name on LinkedIn, Armando Lacerda. Or I don't tweet much, but if you want to connect with the tweet, that would be a great thing too. I really like to have people connections with people through LinkedIn. It's awesome professional social network, I think. I hope you have enjoyed, and I see you in the next webinar. Thank you, Martha, for your support.
Thank you.